This technical paper, titled "The Space Escalator Carousel's Unique Potentials," was one of 3 papers I wrote and submitted to the Space Engineering and Science Institute's Space Exploration 2005 conference. The 3 papers were eventually published in the conference proceedings, although with disrupted graphics, the book on the right side in this photo. It was a long drive from Los Angeles area to Albuquerque, New Mexico and back again. I did stop to see some sights along the way, however. All the costs of doing this paper and this presentation were borne by myself, so relaxation when possible was part of it all. Here is my conference badge showing that I was a speaker, along with my first iPod whose music helped me think and relax at times. And here is my trusty iBook, which I had bought as a backup for when I did my ASCE Space 2000 technical paper on KESS to GEO, and has been a primary conference presentation tool for me ever since. A self-photo in my suit, tie, and badge, taken in the hotel room mirror. The conference site, the Albuquerque Marriott Pyramid North Hotel in Albuquerque, has a spectacular interior plaza with a prominent elevator visible on the right side of this photo. This KESS to GEO concept was originally created in 1989 to do a space elevator function, while bypassing the tether's severe strength to density limitations, but it has been suppressed during the 22 years since then. The viewpoint here is that this conceptual design ties together several normally unrelated mechanisms to perform a new kind of function which has the potential for providing a pathway to a large-scale expansion of civilization into nearby space in the relatively near future. First, let's look at its potential benefits. Why we would want to build such a thing? It would provide electrically powered access to the geostationary Earth orbit from the ground, bypassing the need for high-strength tether materials, providing rapid and continuous access between ground and GEO, and enabling large-scale construction in GEO to provide the Earth with abundant solar power satellite electrical power for the world, total recycling of industrial civilization's worst toxic byproducts, high spaceports in GEO for rockets to explore and develop the solar system, and to bring up materials for building the prototypes of large-scale wheel-type space habitats originally envisioned for construction in L5 from lunar materials, but now buildable in GEO out of Earth materials for R&D purposes. Let's look at how it would work. It is essentially a large perimeter, synchronous electric motor connecting the equatorial ground with GEO. Its shape would resemble an elliptical orbital transfer trajectory between ground and GEO. The electric motor's Earth stationary part contains high-speed inductive magnetic levitation tracks and encloses a hard vacuum throughout the path of the high-velocity armature segments. The motor's rotor or armature consists of continuously flowing high-velocity electromagnetically coupled mass, selected to provide the amount of mass and velocity to result in outward centrifugal force to support the stationary part of the structure and its live loads. Such a dynamic system depends on the force upon a track that is exerted by moving mass that is being deflected from a linear path by following the shape of the track. 2 configurations of such a kinetically supported structure are shown here. On the left is a circular structure occupying an orbital position above a planet, but has planet stationary structure that is supported by the internal high-velocity mass flowing within itself, moving at far higher velocity than orbital velocity at that altitude. This would be useful such as in an equator encircling transportation structure, linking very high-pressure strengthened towers located around the globe. On the right side of this slide, the eccentric hoop form is shown, which uniquely would connect the equatorial ground with much higher altitudes above the far side of the planet. Along the eccentric hoop structure, the captive spacecraft are lifted by electrodynamic drag against the upward-bound armature mass stream. The captive spacecraft slide along additional magnetic levitation tracks located on the outside of the Earth stationary stator motor structure. Let's look at how this goes together. First, here is the Earth, since this application has the intention of enabling Earth to space access. The principle could also be utilized on other planetary bodies, moons, or asteroids too. Adding the eccentric hoop space carousel motor stator with its tracks, enclosing a hard vacuum where it is within the planetary atmosphere. Add a portion of the geostationary Earth orbit, shown as an arc here. The energy input to the structure, in this configuration, is done by an electromagnetic synchronous mass driver facility located at the Earth surface terminal, shown here as number 4, shoving the armatures as they pass through the facility and shoving against the mass of the Earth as reaction. Add in the high-velocity armature segments, part of them illustrated as number 5 here. Add in some spacecraft being lifted along the outside of the motor's stator hoop structure, shown as number 6 here, and some captive spacecraft being gently lowered, showing here. Let's focus now on its construction, operation, and maintenance. An east-west tunnel made through the Andes Mountains on the equator could be a ground terminal site, for example. From this tunnel, 2 possible ways to build the structure are mentioned. One is to build a seed structure as an air flotation structure around the world, which would support the seed microscale evacuated tubing and armature mass stream, to subsequently speed up developing outward centrifugal force, lifting the structure up from there. This technique enables the controlled raising and lowering of the structure for maintenance and repair, especially in the early developmental stages of the project. Another technique is to self-emplace a seed structure using millimeter diameter tubing with expendable microarmatures, whose injected velocity shoves upward on tubing and at the forward end provides thrust as the microarmatures are ejected backwards from the rising endpoint, simultaneously going in opposite directions from the tunnel in the mountain. The 2 growing arc sections would, somehow, meet and lock along grooves in each other to continue on around the planet to complete the 2 laterally attached internally counter-rotating mass streams within the pair of evacuated tubes. If the armature mass streams are speeded up to, say, 4 times orbital transfer trajectory velocity at their altitude, they can support laying of the next set of trackways equal to twice the preceding structure's weight. Laterally coupled trackways enclosing counter-rotating mass streams will be used so as to balance gyroscopic precession forces and to provide upward moving armature mass streams along both sides of the hoop. Since this would be a dynamic structure in continual motion, servo positioning by differential lateral forces to compensate for wind forces and changing live loads, a major portion of the effort is to provide continual instrumentation of each component and appropriate interface to automatic monitors and maintenance personnel. Provision needs to be made at the tunnel site for temporary diversion and storage of armatures while damage repair is done to that set of trackways. Note that the armatures travel in an overall cycloid path of their path around the hoop, which is itself rotating in the 24-hour rotation of the Earth. Let's now examine some space applications that could be enabled by this transportation structure. Potential energy costs are in the range of a few dollars per kilogram lifted from the ground up into GEO. This low energy cost is key to enabling large-scale applications in GEO and thus expansion of civilization into high Earth orbit. The actual cost of energy and infrastructures determines which applications become feasible to be built and utilized in GEO. Looking back at our overall diagram, we first move nearly all launch and return of reaction engine spacecraft up to spaceports built in GEO, far above the atmosphere and 91% up out of Earth's gravitational energy well. A great head start for ventures to the Moon, Mars, and the asteroids to gather construction material. Construction, finally, of the long-envisioned solar power satellites in GEO, delivering carbon dioxide-free, toxin-free, solar-sourced energy via electromagnetic power beams wherever desired around the world to rectana sites. Our industrial civilization produces huge amounts of toxic industrial byproducts that Mother Nature cannot recycle. So, simple mass spectrometer, total recycling facilities, could be built in GEO to use solar energy to convert the toxic materials into a plasma of component atoms, shoot them past a magnetic field, bending their individual paths according to their mass-charge ratio, to be collected in containers located at the associated bent trajectory positions, thus converted back to their pure material form for reuse. The transportation structure could even be used to lift the huge amount of materials to build one or two research and development versions of the Stanford Taurus 10,000-person space habitat, built in geostationary Earth orbit out of Earth materials instead of at the Lagrange 5 point out of lunar materials. The huge debugging could be done there in GEO, laying potential design for building more of them later out of lunar materials. In this slide, the GEO terminal site's location is pointed out. In summary, here we have explored a diverse set of mechanisms not normally considered involved in space transportation, as assembled into an escalator-like hoop-shaped lifting structure to operate between the equatorial ground and geostationary Earth orbit. It is hoped that the electrically powered lifting efficiency will approach the 15.7 kilowatt-hour per kilogram or 7.3 kilowatt-hour per pound mass of the energy actually added to payload during movement from the equatorial ground level up into geostationary Earth orbit. The intent is to provide a way to solve many upcoming crises facing civilization, such as the need for clean, abundant electrical energy worldwide, thus reducing greenhouse gas production, provide total recycling of toxic industrial byproducts and discarded products, converting their high entropy composition back into their pure elemental forms for reuse, provide sustainable economical space resource access, and new room for civilization to grow in the relatively near future. And, in general, the space escalator carousel form of space escalator could provide wholesome new direction to the drama of people in the flow of civilization in the near and distant future. For recent developments, please visit the website www.kestsgeo.com and email jedcline@kestsgeo.com with your comments and questions. The published paper resulting from this effort appears in this book, Space Exploration 2005, published by the Space Engineering and Science Institute, cover partially shown here. As mentioned before, the paper's graphics were altered as printed, specifically by ungrouping and moving all the elliptical hoop parts of the graphics as seen here on the second page of the technical paper as printed. And the ungrouping and displacement of the hoop ellipses continued in the graphics of these two pages. Without proper graphics, it is hard to convey the concept. This alteration seems to be consistent with the hostility experienced throughout the conference and presentations by the author.